What's going on, guys? It's Mr. Aguilar here. Just trying to get you guys caught up for that day. So I'm hoping you guys are able to get to 7.2 addition and subtraction formulas. You guys will need your trig sheets today. These are the formulas you guys will be using. And what is also helpful is the bottom trig sheet. Okay, we're going to be using that in a couple of minutes. Looking at the bottom portion, the unit circle has 30, 45, 60, 90, all the way around 330, 360. So we're going to be using those. You also have them in radians, and you can kind of correspond them identifiably. So you don't need to copy this down. Copy down the top addition and subtraction formulas. Objective, understanding, and apply addition and subtraction formulas. So you guys will be verifying from yesterday's assignment, and then you'll also be doing this portion. There is 7 problems today. I believe there is, I think, 10 or 11 slides we're going to be doing. So here we go. The steps to using addition and subtraction formulas goes as follows. We're going to use a unit circle. So what we're going to get here is we're going to get sines, cosines, and tangents that add or subtract up to values located on the unit circle. And what we want to be able to do is find 2 terminal points, or either be radians or degrees, and we want to be able to find a way to either add or subtract them to get the value we're looking for. So to begin with that, the unit circle, find 2 terminal points that either add or subtract for the even for the even degree or radians, even for the degrees or radians. So check for either radians or degrees, and we'll talk about that. We're going to use trial and error. We'll always be able to find them, and this is why your unit circle is going to be crucial for us. And then we're going to find and identify the formula that it's going to use, whether it be sine, cosine, or tangent, and then we're going to solve. So we have several examples to show you guys this. You can pause it, go back for these. So we're going to kind of jump ahead. The formulas are on your sheet. In this case, they're located at the middle portion, this middle portion up here. So we want to be able to use these values here and solve out. These are the first 2. So let's go ahead and copy these down. And here we go. Looking at the sum of these values, for some reason it's not doing this, so give me a second. So let's look at this real quick. The first thing that we're going to do is we want to be able to apply the sum and differences of our values. And as long as you can make these values up on your functions or on your unit circle, they're going to be values we can find out. So it says find the exact value of the expression, meaning it's easy to plug these into a unit circle, but in the event that you don't have a unit circle, you need to be able to show me and use these formulas, these sum and addition formulas, in order to help you solve for these values. I don't know whether I'm going to give you guys a calculator because we haven't used them. So if I don't give you them, you can't just plug this in and tell me what it is. So you got to be able to express that in a different way. Located on your unit circle, okay, can you find me a number that adds up to 75? And if you look on it, all numbers between 60 and 90 there's no value or no general terminal point that we can use. So we got to be able to find 2 numbers that if I were to split would give me this value. And this first one coming here, looking at the 2 numbers that I can locate on my unit circle, I can rewrite this as the following. It'll be cosine of 45 plus 30. Because if I can rewrite it like this, 45 and 30 adds up to 75, and I know 45 and 30 exist on my unit circle. So this is how you want to be able to develop it. So looking at our values here, we're going to use the cosine plus s plus t is equal to our value, or we can just plug in these values that are representative here. And that's exactly what we're going to do. We're going to do cosine of 45, cosine of 30, and then we're going to subtract it from our sine of 45 and sine of 30. Okay. And we want to be able to simplify this out. So what we're going to do here is looking at cosine of 45. Okay, looking on your unit circle, cosine of 45 is going to be radical 2 over 2. So we're trying to show the exact number for this. And then cosine of 30, which is one right above it, is 1/2. So we have to multiply those two. We're going to subtract. Looking at sine of 45, so sine of 45, I just mess this one up, cosine. I just messed this one up. Sorry guys, I made a boo-boo here. Sorry, cosine of 45, I looked at the wrong number. Cosine of 45 is 2 over 2. Sine is 3 over 2. Subtracting, sine is going to give me rad 2 over 2. And sine of 30 will give me 1/2. My apologies. My apologies. And all we really want to do is simplify out these. So on the top, what we're going to get here is multiplying rad 2 times rad 3 gives me rad 6 over 2. And then if we subtract them, we're going to get rad 2 over 2. Rad 2 over 4. So I'm messing these up today, guys. Rad 2 over 4. And then we can actually simplify this to get rad 6 minus rad 2 over 4. This is the exact number. I don't require you guys reducing this down. So that's our solution. So cosine of 75 in the exact form using the sum and the subtraction problems of law of sine, cosine, and tangent is going to be rad 6 minus rad 2 over 4. So this is one of them that you guys can do. Pause it and go back and look at them. Okay. Even if I'm giving sines, okay, even if I'm giving the sine one, you're going to do a lot of trial and error, right? Take your values and do do pies, do different versions. If you don't like this, you can also convert this into the other form, which is going to be your form of rad 2 over 12 multiplied by 180. You're going to get a specific value. You can always convert these back to degrees and solve it out that way. But just for practice, I'm going to go ahead and use it in this format. When you solve this out, I found out that sine can be split up by pi over 4 minus pi over 6. This is the exact equivalent of pi over 12. So now we're going to use our sine formula, the subtraction version of this. And so that's how we want to be able to apply it. Let me try to keep it in frame for us to help me out solving. So this will be sine of pi over 4, which is in radians, cosine of pi over 6 minus cosine of pi over 4, and sine of pi over 6. And so this is what I have for my solution. Again, S is going to be pi over 4. T is pi over 6. All we're really doing is identifying by splitting up the single fraction and reducing. Looking at your unit circle again, I would look just at this chart, or you can look on your graph. I would just look at this chart. Sine of pi over 4 is rad 2 over 2. Cosine of pi over 6, so cosine pi over 6 is rad 3 over 2. So we're going to multiply those two together. We still have the subtraction. Cosine of pi over 4 is going to give me rad 2 over 2. And sine pi over 6 is going to give me 1/2. And again, all I'm doing is I'm reducing down and simplifying. Kind of zooming in on this. We're going to get rad 6 over 4, subtracting rad 2 over 4. And we can reduce this down again. Rad 6 minus rad 2 all over 4.
Did you want me to come back? Or?
Oh, no, you can come back. Yeah, no, you can work. I'm just, okay. Yeah, recording. You're good, man. Sorry. Custodial's coming in, guys. Thank you very much, by the way. So rad 6 minus rad 2 over 4, which I believe might have been the same answer before. These are going to look very similar. The solutions are all going to look very, very similar when you solve out. The only one that will not really look out the same is when you use tangent, and we'll get to that one in a bit. So clearing this, I'm going to do the next one here. So this is just practice and just kind of showing you guys. So if you want to pause a video and check this part out, you're more than welcome to. Let's try out the next one. So I'm just going to kind of go through these. You can zoom ahead if you want to, or practice these one out. I would highly recommend you guys copy these and try to make sense of it. If you have any questions, remind 101 me, and I'll be more than happy to get back to you. So I need to find two numbers on my unit circle that can add up to 107 or subtract out to 107. You can use either case. For my 107 or my 105, I'm going to do sine of, I've already did these, so I don't have to worry about it, 45 plus 60. Right? 45 exists on the unit circle and 60 exists on the unit circle. I'm going to use the plus version, so this is going to be, let's kind of change up my colors for these. Let's use my markers. Thank you, man. I appreciate it. We're going to use a formula at the top in order to get our value. So let me kind of, so we're going to use that one to help us solve it out. So again, I'm splitting them. I'm using this as a way to rewrite it to solve using my unit circle. So the tippy top of that would give me sine of my s, which is 45, cosine of 60, plus cosine of 45, sine of 60. And again, we would want to approach, so now we're just doing the simplifying, right? So we're going to look and approach our unit circle to try to solve. Sine of 45, so sine of 45 is rad 2 over 2. So this is one of my terms. Cosine of 60, cosine of 60 is 1/2. Then we're going to add it to cosine of 45. Cosine of 45 on my side, rad 2 over 2. And then sine of 60. Sine of 60 is rad 3 over 2. Sorry. Sine of 60, rad 3 over 2. So we have these two that we're going to multiply and simplify. That's essentially what we're doing here. Multiplying the top two numbers, we're going to get rad 2 times 1 is just rad 2 times 4. Plus rad 2 times radical 3 is going to give me radical 6 over 4. Again, these are all going to look very familiar. Rad 2 plus rad 6 all over 4. This is our value. We're done simplifying. Okay, so that's our solution for that one. The next one to our right is using, it's already telling us what it's going to use. It's already going to use cosine, which is our subtraction one down here. Let's look at that part. So we're going to look at this cosine subtraction of two radians. And radians in pi over 3 and pi over 4 exist on the unit circle. They exist in the first quadrant, so I know I can use this. I know I can find them on my unit circle. So let's go and solve. Using this formula, we're going to see that our s's matching up with our parts here. The cosines are going to match up with our terms here. So in case you need to find that out, there you go. Kind of blocking this out for us, giving some more room. We're going to do cosine. We're finding cosine of s, which is pi over 3, cosine of pi over 4. Don't worry about that negative. It encapsulates within the formula. And then we're going to do the addition. So we're going to say sum of sine over pi over 3, cosine, I'm kind of losing room over here. So cos, sorry for the tight squeeze right there, of pi over 4. Okay. So again, all we're going to do is convert our values using the unit circle. Unit circle for cosine pi over 3. So looking for cosine pi over 3 is 1/2. Just look for it. Here's all I'm doing. Looking at my unit circle. So cosine of pi over 3 is right here, which is 1/2. So I want to be able to identify my values here. Cosine of pi over 4. We'll look at what cosine is. Cosine pi over 4 is rad 2 over 2. And then we're going to use a sum And then sine of pi over 3, so sine pi over 3 is radical 3 over 2, followed by cosine of pi over 4. Cosine pi over 4 is rad 2 over 2. So all I want to do, cosine pi over 2, cosine pi over 4, it's 2, yes, okay. And again, just simplify. Doing our first terms here, we're going to get rad 2 over 4 plus radical 6 over 4. We can reduce this down one step further. Rad 2 plus rad 6 all over 4. So this is the methodology of what you want to be able to use and solve when using these types of formulas. So the adding subtraction formulas are applied to these types of problems. Find the exact values of the expression. So we're going to use that for these, okay? So you can pause it, go back. We're going to keep on moving along here. Tangent. So let's look at doing a tangent one. Tangent, we can still split up, like we're still using this formula here. So tangent for this one here, excuse me. Find two numbers that add subtract on the unit circle. So you have a wide variety, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, all the way around the unit circle. That adds up to 300. Or subtract that to 300. I like the addition just because it's easier for me. When I'm looking at this one, I'm going to do tangent. So I've already done this one. I've looked at it, and I did trial and error. You can look at them, and just they should be easy numbers for us to do. Tangent of 300, I'm going to split up to 270 plus 30. Right? Like anywhere on there is going to help us get value. So use it. We're going to use our top formula here. So we're going to use the tangent formula for this one. So it's going to be highlighted in the blue here. And S in this case, and maybe if I need to make this clear, S is going to be my 270. T will be my 30. And I'm going to go ahead and resubstitute those values in. So tangent of this case S, or 270, plus tangent of T, which is 30, all over 1 plus tangent 270, tangent of 30. And again, you have these located on your unit circle. Thank you very much again. Appreciate it. Guys, just leaving the room. And again, look at your unit circle. Your tangent bar is right here. This is what we're going to look for. And we want to be able to solve those out. So tangent of 270, undefined, meaning there's no value. So we can just leave it as 0. I'm going to use that one. I'm not sure. There are two other solutions for this. Give me a second. Pause this. Plus 90. We'll keep on working with it. Let's just check it. I need to make sure before I keep on going with you guys. Okay, let's check it. So let's kind of just go back. In this case, the tangent. Okay. In this case, tangent of 270 is undefined, so we're just going to cancel it out. So anything with tangent of undefinedness. So it'd be like multiplying, so this is going to go away as well. I want to see if this is doing it right. And I think there's going to be wrong here. Is there any other numbers that we can add up to give us, or subtract out to give us 300? So 135. 120 plus. So let's do it a different one. So I'm sorry, guys. Let's clear this. Let's look at two different numbers. If you did it the other way, tangent of 330. Let's do numbers that will actually work. Let's do those two. Can't have any undefined values, I don't think. So let's do it this way. I'm going to use the subtraction version, so I'm actually going to use it differently with these ones. This will be tangent of 330 minus tangent of 30 over 1 plus tangent of 330 minus tangent of 30. So the condition is, I guess, we don't want to use values that are undefined here, and I'm guessing that's going to be the case. So we can't really solve it if it's undefined for certain values. So tangent of 330 is rad 3 over 3 minus tangent of 30, which is going to give us rad 3 over 3. Is that right? 330 minus... Why is this not working? 330 tangent of 330. I don't like this one. I don't like this one. Let's just see what happens. I know this is not doing the right way, and I hate teaching you guys the wrong way, but radical 3 over 3, tangent of 30. Why am I doing this? Why is it so weird? S, maybe one of them is negative. I think one of them is negative. Am I messing this up? Tangent of 330. Oh, yes, this one has to be negative. One of them has to be negative. I think this one has to be positive. This one has to be positive. This will give us rad 3. Oh, I don't like doing this one. Tangents are always a wacky one, so I'm just going to leave it like that. Because I want you to be able to simplify it. So let's skip it. Let's skip this next one. Can we write it as a simple fraction? This will work out quite nicely. So let's plan to give you guys one like this one. I want to be able to identify what kind of category it's going to fit into and where can I find the solutions for this. In this case, it's looking like it's going to follow from the bottom one. The bottom one seems to be the same kind of setup for this. So those are the two that I'm going to use for this. That basically tells me that I can rewrite this as tangent of s, which is 35, plus tangent of 25. And this will give me tangent of 60, right? 35 and 25 is 60. And then we should be able to look at our unit circle here. Tangent of 60 is rad 3. So this one's a little bit more simpler. My apologies for that last one. Okay. Here we go. Let's keep on going. You can try these ones. Let's try the tangent one because I still don't like how that one came out. This one should be 15 and 30. So let's try this one. So I'm going to find two numbers. In this case, the two numbers that we're going to do is 45 and 30. Let's see if this one kind of works out. Maybe I just didn't choose a good number. 210 you guys can do later. I want to be able to use my bottom one. And we're going to go ahead and set it up. So tangent of 45 minus tangent of 30. 1 plus tangent of 45 tangent of 30. And again, we're going to set these parts equal, and we're going to find out what those values are on our unit circle. So tangent of 45 is 1 minus tangent of 30, which is rad 3 over 3. The bottom one is going to be 1 plus tangent of 45 is going to be multiplied by 1. And tangent of 30 is rad 3 over 3. So this will be working out a little bit nicer. For the top one, let's find the common denominator. This will be 3 over 3 minus rad 3 over 3. The bottom one, if we were to reduce this one down 2, can simplify that. We're going to get, again, finding the common denominator, 3 over 3 plus 3 over 3. We can reduce both of these parts down. 3 minus rad 3 all over 3. 3 plus radical 3 over 3. Multiplying by the reciprocal, because they're just the longer ones. I just don't like these long ones. Multiplying by the reciprocal, this is what we're going to get. Multiplying by the reciprocal. We have two terms that cancel out, and we're left with the top part minus rad 3 all over 3 plus rad 3. Again, just multiplying these tops up. This will be our answer. So I'm okay with you guys leaving it like that. You guys don't need to go any further. I don't even know if I'm going to give you guys problems like that. So those are them for you guys. Again, these are more simpler types of problems, and I'll put these on Thursday's review. But it says find the exact value, so we can always rewrite this. Essentially, what you want to be able to do is write the expression that it represents, and we can use these law of sines and cosines to find those out. So we're looking at this one, which cosine, sine, cosine plus cosine, sine. So sine, cosine plus cosine, sine. So it looks like it's going to be this top one here, the tippy top. So let me do a different color for this. So it looks like it follows this top written part. This tells me I can rewrite that as a sum of two values. So sine of 20 plus 40. These are fairly easy for you guys to do. Sine of 60. Again, looking at your unit circle. Sine of 60 is rad 3 over 2. So that's what I'm looking for. Now these are fairly straightforward. Try out the next one for me. In this case, it's going to use degrees and radians, and I think we just did that one. Sine, cosine, cosine. Yeah, so this one was rad 3 over 2. We should be able to find the other one for our value. For the bottom one, it looks like it's going to be cosine, cosine, sine, plus sine, sine, cosine, cosine, plus sine, sine. It looks like it's going to follow this one here. It's going to follow from that one. And essentially what we're going to get here is cosine of 3 pi over 4 minus pi over 2. And if you guys look at that, so take a half away from 3/4, you're going to get cosine of pi over 2. Or no, cosine pi over 4, sorry. Take a half away of 3 of 4. Yeah, take a half away. And then simplifying. Pi over 4 is going to be, of cosine is going to be rad 2 over 2. These are fairly straightforward. So those are going to be your type of problems. Practice those, go back and copy them down. Email me if you have any less questions on those ones. So yeah, these are what we're going to look at. So these, whoa, let me see what I see, guys. These are going to be your homework problems. You have ones that I believe we've already done, or very similar to them. 1, 2, 3, 4, and then these two types of problems. You might need a calculator to find out what these values are going to give you, whether it's adding or subtracting for your laws of cosine, or addition and subtraction of law of cosine and sines. So those are your problems today. Check those ones out. They should be pretty straightforward in solution. use your work in order to help you guys out. I'm Mr. Aguilar. You guys have a worksheet tomorrow. Be good to the sub. I'll see you guys later. Okay, bye.